I'm recording already. I'll wait till 2:10 to start. Kind of weird looking at my face. I'm gonna change to something else. Kind of weird. I feel weird. What do I change to? I like this one. Let's do this one. Hello. Hopefully, new people who just came in don't get scared. There is another scary one. Let me use another scary one. I'm having fun. Where is it? Oh, this one. Okay, let's stay like this for a while until it's 10. Oh, you can still see my glasses here. Okay, I don't want to scare too many people. Let's go back to my pumpkin face. Pumpkin is cute, not scary. I feel bad for people who would click into my YouTube video and see the first thing. There is like a skull or something. Pumpkin is cute. Raspberry pie splatter. There are other ones that I want to try. Let me get another one. Oh, this one. This one's really. I like this one too. It's pretty. Where is you're in the reverse? Do you guys know that a student said I am like the girl from the Ring, you know, the movie Ring. They said I'm the girl from the Ring. I always wanted to do that during Halloween, but it's too cold for me. So I should do this. If ever I'll go, I should do this. You know, and then crawl out from your screen. What did I do? What did the girl from the Ring do to you? Anyway, it's 2:06. Let me talk about something that I wanna talk. This might be too scary. I think I'll change to something less scary. What about this one? Is this one better? Let me know what you think. Or should I use the one from my last tutorial? Nobody said anything. Or this one. This is the one I used from my last tutorial. What about this? This is pretty nice too. Or I can be a cat. I actually got scared. I can be a cat too. Hello. The first one? What was the first one? The first one was the pumpkin one, right? Where is my pumpkin? Pumpkin? This, you like this the most? No? So what was the first one? Not the pumpkin. This one? Are you talking about this one? or this one, or this one. I think those are the ones I used. This one? I am confused now. After the one with the pie. Pie? This is a pie you're referring to? So you're talking about this one. It's Halloween, come on guys, Halloween. Has a pie in its mouth. Which one has a pie in its mouth? This? No, it doesn't have a pie in its mouth. 1 sec ago. This? This one? Yeah. I don't want people to be too scared. This is interesting. Someone's drawing already. Okay, let's use a not so scary one. Um, let's use this. Let's use this. Okay, because I don't want it to be too scary. I feel bad for the people watching videos. There we go. Let's use this. So, what I want to talk about, it's right at the time. It's 2:10 now. Tutorial worksheet will be sent to you. This is the tutorial worksheet. Um, sorry, I apologize if it's too scary for you. Okay, let's switch to the pumpkin now. Pumpkin is not scary. Let's do the pumpkin. No? Okay. Okay, fine. Fine, fine, fine. Up to you. I don't really mind. So, back to tutorial. I know you have a test. I cannot do a full test review because you guys covered a lot of material. It's not possible for me to do everything. And plus, we haven't talked about contrapositive and contradiction yet. This will definitely be one of the 5 questions. The other one's not guaranteed. This will definitely be tested about. So we'll do contradiction and contrapositive. And as you can see from the file, I prepared I prepared 8 questions, which means it's impossible for me to go over everything. That is why you can see some of the questions are done already. Why? Because I did half of the 8 questions in my last tutorial. So we will do the rest 4 in this tutorial. If you want solution for the other 4 questions, you are welcome to check the video. Okay, the video for the first tutorial it's already posted. So you can check that if you want a solution um for other questions. I got 65 students. Wow, okay. This is scary because next semester, you know what? This worries me because next semester, if it's in person, the tutorial rooms can only have 40 students. That means 25 of you will be stand up there. Um, Not really. I've had this situation before. Yeah, this is only possible online. This is in person. I've had the same similar situation before. My tutorial room was all full, and I had to ask them either leave if they're not my student. They had to either leave or they need to stand up. So they grab chairs from other tutorial rooms, and they VIP pass. So they got grab chairs from other tutorial rooms and they squeeze in. It was pretty crowded in my tutorial room, but it happens many times, so it's pretty, it's not too bad. Yeah, sometimes they just really full, but online there's no problem. I think the limit is like 300 people. I don't think I'll get 300 people in my tutorial, so it's okay. It's not a big deal. You can stay. Oh, okay. That's like 70% of 102. No, 102 has like 1,000 students. I think some of them dropped already, but still a lot of students. Yep. Anyway, back to tutorial. Drop date is November 10th. Are you guys gonna drop? Actually gonna drop? Gonna drop this course? Depends on how the midterm goes. The midterm, I will I will remind the TAs to mark every day and make sure you get the marks back before November 10th. Okay, I'll make sure you get the back before the drop day. You're too deep now. Okay, cool. Tutorial. Tell them to be kind. I I told them to be kind. Like okay, like last quiz, I actually asked my TA to remark twice after they marked one of the question. I saw the results. I was like, oh, this doesn't look good. You need to. I was like, sorry, you need to remark. Like after they graded the first 20, I was like, oh, doesn't look good. They need to remark. And then they remarked the first 20, and then I checked the next day. They finished like 65 students already, and I checked the result. I was like, this looks not good. You need to remark again. So before the remark, the average for the question was like 22%. After the remark, it changed to 50 something percent, which is much better. So yeah, if they're being too harsh, I'll make sure to remark the questions. But which question? I'm not telling you which question, and I'm not telling you the TA's name. Okay, not telling you anything. Yeah, I have to protect the TAs. Can't let you go knock hunt them down. Then nobody's gonna mark for me. Not mark for me. Mark. Nobody's gonna mark. Then I'm gonna be sad. The other TAs would have more work to do. I would have more work to do, so don't do that. I'm not telling you any names. All right, tutorial. Today we're going to do contrapositive and contradiction. I prepared 4 questions for contrapositive, 4 questions for contradiction. I did two in my last tutorial, so we'll do the rest of the 2 for this tutorial. First of all, contrapositive. Contrapositive only works when you have P implies Q. Okay, if you don't have P implies Q, then there is no such thing for contrapositive because it only works for P implies Q. This is used when proving this is too hard. And we realize that, oh, proving this is much easier. Since we know they are logically equivalent, okay, they are equivalent, which means if you prove this is true, that implies this is also true because they have the same truth value. Okay, and when do we use that? I have written it here already. The first case is, by the way, your professors really like to test you on even or odd. Okay, so the first case is if they gave you a really large expression and they said, oh, prove that if this large expression is even, then x is even, or change it to odd or something like that. What is going on? Okay, and you can prove it's contrapositive because assume that x is even or x is odd, and then plug it back into the large expression is much easier from going from a large expression to x itself. Okay, so if you see something like this, most likely you will be using contrapositive. The other case is when they have if something, 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 not something, something, then something, not something. For example, I use not equal here. Okay, in this case, you can also use contrapositive because two things are not equal, then they have many cases. But if two things are equal, you know, well, they're equal, so it's much easier to deal with equality than inequality. Okay? Did you guys hear that? It wasn't not a knocking door. I think it's, I don't know. It's from upstairs. Okay. Anyway, so those two cases, if the question didn't tell you which proving technique you need to use, and you see something like this, those are telling you, oh, you might need to use contrapositive. Okay, so that's contrapositive. Let's do this question. Oh, stop. This is bothering me. I don't know. This is really funny because at night I keep hearing the drawing thing. I don't know who's drawing like in the midnight. It just and then after a second, after another second, and I was like, can you please stop? I can't sleep. But yeah, and in the daytime we have this. I don't know what's going on. Just really funny. Okay. You know, your place might be haunted, right? I have my dog to protect me. My dog's gonna protect me. Brownie's gonna protect me. Brownie's sleeping. Remember, Brownie sleeps with his eyes open, so even if he's sleeping, someone comes in, he can protect me because his eyes are open. Did you get your dog a Halloween costume? No, he's too big for that. It's a huge boy. Anyway, do questions. We check too much. Suppose that x and y are positive real numbers such that the geometric mean is different from the algebraic mean. Use proof by contrapositive to show that x does not equal to y. Okay? What does this mean? This means that, oh my God, if, so this is saying for all x, y bigger than 0, if xy, square root of xy does not equal to x plus y over 2, then x does not equal to y. As I mentioned, look at this. This is exactly what I said here. Right? When we have does not equal to, then we use contrapositive to make them equal. So can someone tell me what is my contrapositive here? Contrapositive?
If root xy equals x plus y over 2, then x equals y.
No. What is the contrapositive of P implies Q? Okay, someone type in the chat. Yeah, do you want to fix your answer?
If x root xy does not, no, root xy does not equal x plus y over 2 and x equals y.
No. Contrapositive. Contrapositive is this. P implies Q.
So you're right, if x equals y first, sorry.
So if x equals to y, then square root of xy equals to x plus y over 2. Okay, this is quite important because for contrapositive questions, a lot of students will get their contrapositive wrong, then you get 0. Okay, then you'll get 0. Now, suppose x equals to y. Okay, then we have what? then we have square root of xy equals to this, right? This is because x equals to y. What does this equal to? This is absolute value of x, which equals to x. Why? Since x is positive. Okay, which equals to x plus x over 2, which equals to x plus y over 2. Okay, again, this is because x equals to y. So I showed that this equals to this. That's exactly what I need to prove. So we're done. Let's draw a smiley face. Okay, we're done. What if I choose to square everything? Square everything? Square everything here?
Yeah, so like essentially square everything so that you can sort of, at the end of your proof, reach x equals y.
No, because here, this is what you need to prove. You cannot start with what you need to prove. So if you do that, you are trying to prove this way, which is wrong. Okay, that's the converse.
Okay, all right.
Can you say it's AGM so it's true? No, because the question is basically asking to prove AGM equality holds when x equals to y. So you cannot do that. How did you get x plus x? This equals to this because this is 2x. 2x over 2 is x. Okay. This is a formal proof. Of course, it's a formal proof. Any other question? Because 0 is not positive. 0 is 0. It's not positive or negative. So when they say it's positive, it means it's strictly greater than 0. Okay, so move on. Since you guys are answering each other's question in the chat, so I'm gonna move on. Let's do question 3. Use proof by contrapositive to show if this is even, then this is odd. So someone tell me what is my contrapositive for this one.
Isn't it going to be if x is even, then that whole statement is odd?
Yep. Okay, if x is even, then x squared plus x plus 1 is odd. Since x is even, okay, x is even, what can we write it as? X equals to 2k. Anything else? Make sure you complete. What is k? Oh, by the way, they should have a quantifier says x is integer to show that for all integer. They should say this, okay? For all integer x. K is an element of natural number. That's not all the even integers. K should be integer, okay? So Now you can substitute back. So x squared plus x plus 1 equals to 2k squared plus 2k plus 1, which equals to 2 times, you want to write it as 2 times an integer plus 1. So that's 2 times 2k squared plus k plus 1. And you can say since k squared, 2k squared plus k is an integer, x squared plus x plus 1 is odd. And that is the end of my proof. Okay, so few things you need to be careful. One is make sure your contrapositive is correct. Two, make sure you define your variable. Define your variable is very important, okay? Define your variables. Okay, if you want to introduce any variables, you should always define it. Yeah, and if you wanna say something is even, then you need to write it as 2k, where k is an integer. If you wanna write it as odd, then you should write it as 2k plus 1. Minus 1 also works, where k is integer. Okay, minus 1 also works. But you cannot have something like 4k plus 1. We know it's odd, but you need to show it's actually odd. It does not satisfy. So 4k plus 1. We know it's odd, but you cannot say directly it's odd. You need to write it as 2 times 2k plus 1. Okay, something like that. So just to tell you, if you see something like that on your test, make sure you define your variable. Make sure you write your even number as 2k, odd number as 2k plus 1. Also, you cannot use the same variable for everything. Okay, if they are not equal, then use different variables. That's it. Let's move on to contradiction. Are we having test review tonight? No. Unfortunately, no. Why? Because unfortunately, no, because I'm really busy. I have so much marking to do that I haven't started yet, and they are due very, very soon, so I don't think I have time. Also, tomorrow, I think I might go out after the class. I will send you what link? What link? What are you guys asking? Oh, also I'm making now nobody's listening to me. I'm making a checklist. So if you were in my last tutorial, you should know I'm making a checklist because I already have many videos. So I'll just send you what videos are, what topics are in what videos, and you can just, it's not finished yet. I'm still going through it. Oh, I have 74 students now. Here, so I'm making the checklist, and for each topic, I'll tell you which video you can watch if you're not sure about that. And at the end, I will tell you which questions I think you have to. If you don't have time to watch everything, I'll tell you which ones you have to know at the end. It's not completed yet. This one is my old version from last year or 2 years ago, so it doesn't have everything. I'll write what I think will be on the test as well. I'll tell you what I think it's not gonna be there, what I think will be there in pink. But yeah, anyway, it's not done yet. I'll finish it today and I'll post it on my Quarkus page. Daria copied me. Daria actually copied me because last time I made the checklist, she sent my checklist to her students directly. And this time, since since she asked for my permission, of course. This time, since I'm really slow, so she decided to make her own checklist. Anyway, oops. Anyway, back to my iPad. I'm trying to put the link in my checklist as well, so you can just click the link. Still trying to figure out how to do that will be better, but yeah. Anyway, next one, yeah, contradiction. Proof by contradiction. Again, I have all the notes here already from last tutorial. This is when you assume the negation of the statement. Okay, so we want to prove by contradiction, you assume the negation of the original statement. And if you can derive a contradiction somewhere in your proof, then you can say your original assumption is wrong, which means the original statement is correct. Okay, so here, this is what you do. You assume the negation of the original statement. So the statement itself, it doesn't have to be P implies Q, but as long as you can find the negation, you're done. Okay, so statements that has negation words usually are telling you need to use contradiction. So for example, no, not, okay, cannot. Such things are negation words. Usually if you see them, you know that, oh, I need to use contradiction. Question 4. You can check the video posted, okay? Let's quickly finish this because I'm hungry. I want to eat. The video for my last tutorial is already uploaded. It's already on my YouTube channel. So for the other solutions, it's already there, so you can check. Anyway, those are for 102. And if you're taking upper year math courses, I also want to say that infinite is another word that's telling you, oh, you might need to use contradiction, because infinite is really hard to make sure you watch the ads. You don't watch the ads. I don't get any money anyway. I didn't monetize it. I don't know why YouTube gave me ads. Yeah, you don't need to watch the ads. I don't get money. Anyway, yeah, so because infinite is really hard to deal with, so for a lot of statements that has infinite in there, you want to use contradiction, assume it's finite, because we know how to deal with finite cases. Okay, so that's another word for contradiction. So when you see something like this, you can think, oh, I might need to use contradiction. Okay, so for contradiction, there are two types of really classic example. One is this one, prove no rational solution. I did it in my last tutorial, so we're not gonna do it. Instead, we will do this. Prove equation has no natural solution or integer solution. They are pretty much the same. They are really similar. Okay, so we'll do this and we will do a failed question. A failed question. I know you hate it, but then we have to do it. That involves contradiction as well. Okay. Contradiction. So let's look at exam question 6. Let F be a field with A in F. Use a proof by contradiction to prove that if A cubed equals to 0, then A equals to 0. Okay, remember, okay, this is really important. Remember, if the question tells you which method to use, then you have to stick with this method. For example, when you look at this, if they didn't tell you it's contradiction, you can also use contrapositive, right? However, since they already told you you have to use contradiction, then you have to use contradiction. You cannot use contrapositive anymore. Okay, so that's really important, because if the question asks you to use contradiction, you didn't use it, then you get 0 automatically. Good for the TA who's marking it, but bad for you. Okay. really bad for you. This is what I usually say. Whenever I'm not marking, I always tell them never ever leave your test paper blank. Because I'm not marking it, so it doesn't matter for me. So good for you. Never leave your test paper blank. Always attempt all the questions. When I am marking, I'm not gonna say it. That's what I'm not gonna say leave it blank, but I'm not gonna say do not leave it blank. I am marking, but please don't leave your don't leave it blank. Okay, don't leave it blank. I'm serious. Don't leave it blank. Attempt and you might get partial marks. Anyway, question 6. Contradiction. So let's make our assumption. Proof. What is the negation of this? Negation of this. This is a P implies Q. What is negation of P implies Q? What I'm saying is a contradiction. Yep. P and not Q. Okay, P, oops. P and not Q. So this is what I need to assume. So for contradiction, let's suppose P, which is suppose A cube equals to 0, and A is not 0. Okay, so that's what you have. And if you were in my tutorial, you should know what does this tell you. Anyone remember what I said when I talk about field? Anyone? Multiplicative inverse exists, exactly. Okay, that's your next step. I don't care what I need to prove, but when I see this, I know inverse exists. So since A is in field and A is not 0, we know A inverse exists. Okay, this sentence is quite important because if you use A inverse but you didn't tell me it exists, then you're gonna get mark deducted. Okay, so what do we do now? We start with A cube equals to 0. Okay, and I'm gonna multiply A inverse on both sides. Okay, and I'm gonna put brackets directly here. That's associative. This is gonna give me 1 times A equals to 0. So this is multiplicative identity. And claim. I don't remember which claim it is. The claim from textbook. Claim something something. You know which one I'm talking about. So well, claim question mark. I don't remember the number. Okay, claim question mark. 2.3.2. Thank you. That's what I was looking for. 2.3.2. Nice. Now, what do? A times A, oh, 1 times A is 1. Oh, it's 8. Whoa, wow, what did I just say? So this is multiplicative. Wait, what did I do? This is not identity, sorry. This is inverse. This is identity. Multiply. I can't spell. Multiplicative identity. Okay, there we go. And you do the same thing, you multiply by A inverse again. Okay, and you put this. Do it again and again and again till you get a equals to 0. Okay, this will give you this. And now it's copy paste, copy paste, copy paste. Ooh, that's bad. I'm gonna remove 1a. That's it. And this gives you a equals to 0. Okay, down. I added brackets, that's it. The brackets. Isn't multiplicative identity 1? It is 1. Here, 1. 1 times a equals to a. That's multiplicative identity.
Can you explain how you use claim 2.3.2?
This claim is telling you 0 times any number is 0 in for all a in field. That's how I got 0 here.
Okay, thanks.
Yeah, you can say that as well. Yeah, for sure. So now you can do that. Yeah. Any other question? Question. Anything. I want to use another filter. Hold on. This is not exciting enough. Shouldn't you mention your contradiction? Oh, I forgot. I'm not done yet. I didn't put my square here. I'm not done yet. I just want to change my filter and continue. So let's use this. This is cool. Okay, so this is a contradiction. This contradicts. This contradicts. A is not 0. Okay, so we have the contradiction. I taught my students from last class oops. I taught them what's the symbol for contradiction, so we'll use the same thing for you too. So it's this. This is a symbol for contradiction. No, I'm kidding. The symbol for contradiction is not this, it is this. This means contradiction. Okay, do you have a question on images? No, not today. Hence our contradiction is false, proving the original statement is true. Yes, exactly. So this is complete now. Can we use emojis on the test? Sure, why not? If you lose mark for using emojis, it's okay. You can ask me for remark. That's okay, because I'm the one who's dealing with remark. So even if you lose mark for using it, I can give it back to you. Question 7. How do you use that contradiction symbol? We don't really use a symbol. So basically, you can basically say, oh, this A equals to 0, contradiction. That's it. It's not like you're actually using it in the symbol. But yeah, this is a contradiction symbol, not this, okay? But I like using this. I actually used it on my own assignment. And whenever the TAs see the symbol, they know it's me. Pretty interesting. Yeah, anyway. You know, some students put memes on their tests or assignments. Pretty funny. I see that a lot. And some students, they draw hearts everywhere on their assignment. I'm like, please give me more marks. And I was like, I'm sorry, you don't deserve it. And some students, they know their proof is wrong. And at the end, they were like, this is all wrong. And I was like, you're right. So I put you're right next to this is all wrong. pretty interesting. Anyway. Question 7. Prove that the equation has no natural solutions. This one is a typical question for such questions. However, you need to think about it a bit. It's slightly more challenging than the ones you've seen before. So I'll give you 5 minutes to think about it. I'll take it up at 50, let's say 55. I'll give you 6 minutes to think about it. So take it up to 55. Think about how would you do this question. It's slightly more complicated than the questions you've seen. I'm pretty sure a lot of you already know when you see natural, so no natural solution, no natural or no integer solution. What do? Contradiction. So you use contradiction. We use contradiction. So never mind. I'm not gonna use it. So this implies that we use it's gone. We use contradiction. Why is it not copying? That's interesting. So we use this. So we suppose there are integer solutions, and now what do? You write it as difference of squares. Okay, so that's gonna give you something times something equals to something. Okay, so you know that the divisors of question mark, talk about divisors of question mark, and that's gonna give you a contradiction somewhere. Okay, so this is like the classic way to do this. However, this question is slightly harder. So you need one extra step to do this. And think about what is the extra step. How do you do converse questions? What do you mean converse questions? Like, what is the converse of the statement? Oh, converse of a statement is this. So if we have P implies Q, then the converse is Q implies P. However, the truth value of those two, they're not related at all. So the truth value of those two, they're not related at all. Okay, at all. It means this is true or false does not imply anything about this. It's the truth values, they have no relation at all. So yeah. Converse. Can I go over steps again? Okay, so you use contradictions. Suppose you do have natural or integer solutions, then you write your as a difference of square. Difference of square, remember a square minus b square equals to a plus b times a minus b, something like that. All right, so you have a product of two integers or two natural numbers equals to another integer or natural numbers. So you talk about divisors of this. For example, if this is 5, we know you can only have 1 times 5 or 5 times 1. So one of them must be 1, the other one must be 5, and then solve for the equation. It's basically classic integer or natural solution questions. But this one is slightly harder, and I want you to think about how to do it. So hot and hungry. I'm so hungry. I have a tiny fan. It's my cat's favorite fan. I want to be a cat. Oh. You think you're just keep it to yourself for now, because I don't want you to spoil the other people. Like, keep it to yourself for now, okay? Give other people a chance to think. You want this girl? Okay, fine. I'll bring it back. Bring it back. Let me show you. My dog is sleeping like this. So funny. He's falling asleep. Oh. Eye open? Oh, I mean, I haven't checked. Let me see. Oh, he's awake now. He's already awake. Oh, it's 56 already. Let's go back to the question. Okay, so let me know what you think.
Can I give it a shot?
Yeah, try.
All right, so we begin with x squared plus x plus 1. We move the y squared to the left. We get a difference of
Hold on.
square.
Let me finish writing the contradiction part.
All right,
So for contradiction, suppose there exists x, y in natural such that x squared plus x plus y equals to y squared. Okay, so you said move y to the other side.
yeah.
What do I do next?
Difference to square,
How do you do difference?
x minus y, x plus y,
So x
and then move the
plus y.
and move the x plus 1 to the right side.
Okay, what do you do next?
And then from there, we can conclude that x minus y equals to minus x minus 1, or x plus y equals to minus x minus 1.
Not necessarily, because for example, let's say for example your x is something like for example your x is 9, let's say 9. Okay, then this side is -10. -10 has many divisors. It's not necessarily 10, -10 and -1, something like that. So no, this does not work. Does that make
But
sense?
yeah,
You don't know if this is this. You don't know. So this is not the correct way. This is correct. What do we need to do?
do you call this? I think that in general, if a number has natural solutions, like we should try it. Like I was thinking of the discriminant basically.
Why are you doing discriminant? Discriminant can only tell you if it's real or not. It cannot tell you if it's natural.
But we can get the value of y for the discriminant from the discriminant, right?
But you can't really. Why is not? Y here is like a constant now. So I don't think that would work.
Oh, but you
Okay,
do it with respect that.
Someone said it. That is correct. In the chat, that's correct. Multiply by 4 for the whole question. Take out 3, then do difference of square. Exactly. 4x squared minus 4y squared plus 4x plus 4 equals to 0. Why do I do that? Because we can complete the square. So this is 2x squared plus 2 times 2x plus 1 minus 2y squared equals to -3. Do you see? This is 2x plus 1 squared minus 2y squared equals to -3. Okay? To get rid of the negative, I'm going to switch those two. So 2y squared minus 2x plus 1 squared equals to 3. This is difference of square. So this is 2y plus 2x plus 1 times 2y minus 2x plus 1, so -1 equals to 3. Since 3 is prime, it only has divisors, we only have, we should say, we only have 3 equals to 3 times 1 equals to 1 times 3 equals to -1 times -3 equals to -3 times -1. Okay, since 2y plus 2x plus 1 is greater than 0, this is saying that the last two are not possible. Or so 2y plus 2x plus 1 is greater than 2y minus 2x minus 1. So we know the only possibility is gonna be 2y plus 2x plus 1 equals to 3, and 2y minus 2x minus 1 equals to 1. So this is your only possibility. Solve for this, just add them together, okay? That's gonna give you 4y equals to 4, so y equals to, let's say, 1 plus 2. You'll get 4y equals to 4. Right. Let me check if I did it right. Yeah, 4y equals to 4, y equals to 1. Plug back in 1. You'll get 2 plus 2x plus 1 equals to 3. So 2x equals to 0, x equals to 0. This is a contradiction. Why? Because 0 is not a natural number. Okay, that's it. Okay, now let's look at what questions do you have. Yes, Lance, what is your question? What's your question?
Oh, I have no question. I just had my hand up.
Let's see. Can we multiply by 3? I don't know if 3 works. But 4 I think is the easiest one. Sana, what is your question?
Do you mind explaining again after the step where we multiplied by 4?
Here? From here to here?
No, from the line above that.
Here to here.
Yeah.
Oh, okay. So basically, you see square, we want, so you know that we want difference of squares. That's what you want. I have difference of squares, but I have something else as well. So what comes to my mind is I see those. I see this, I see this, I see this. So that comes to me complete the square. This is telling you you can complete the square. However, just using this is not enough because when you do, I said you want this to be integer. This is also integer. If you complete the square here, that's gonna be square root of something, right? So that's not gonna work. So the easiest one is make it 4x squared because 4 is 2 times 2. Okay, so you multiply by 4 to get integers. Integers after complete the squares. Okay, because we want integers, we don't want anything else. So multiply by 4, 4 is 2 squared. Okay, that's basically why we're multiplying by 4. I don't think this is the only way to do it. You can possibly multiply by other numbers as well. But this one, I think it's the easiest. It's because it's small number. You don't want huge numbers, you want small numbers, and you want square. So 1 square, the next square is 2 square. So multiply by 2 square, which is 4. And that's gonna have a complete the square here. And also it's integer, it's not weird numbers. Does that make sense? Yeah, okay, cool. Anyway, number 8 is a pretty interesting question. If you don't know how to do it, you should check the video. I posted already. And for questions, other questions, solutions, you can check the video. Yeah, the checklist is not there yet. You mean multiply by 2? If you multiply by 2, okay, if you multiply by 2 here, then you'll get square root of 2x squared. This is not an integer. Does that make sense? So you want to multiply by a squared number. So you can multiply by like 1 squared, 2 squared, 3 squared, or something. Yes, question.
Yeah, I just had two questions, but they're pretty short. I'm a bit confused how you went from 2y squared minus 2x plus 1 squared to the difference of squares. Like, how did you
This?
expand it? Yeah.
Oh, this is because a squared minus b squared equals to a plus b times a minus b. So I added them together.
Oh, I see. Okay.
Yeah, this is how I got from here to here.
Mhm.
What is your second question?
And then for the second question, will you post like the solutions PDF for this tutorial on Quarkus?
Yeah, I can do that. Yeah. Sure.
Okay. Yeah, that's all right. Thank you.
Any hints for the test? I haven't seen your test yet. I don't get to see it until your test, so I really don't know what's gonna be in your test. Bottom 2 lines. This? this volunteer lines, here to here. Which volunteer lines? Wait, oh, this, here to here. 2x equals to 0, so x equals to 0. 0 is not a natural number. We said x has to be a natural number, so it's a contradiction. Does that make sense? 0 is not a natural number.
So just a quick question. I mean, just to make sure I understand, essentially we started off with something and then we multiplied it by 4 so we could have a difference of squares.
Mhm.
And then afterwards, it's just like expanding and sort of simplifying. And then you found the possible divisors to give me that term on the right-hand side. Negative numbers weren't possible, only positive ones were possible. And then we ended up with the two values that our equation could equal to, which was 3 and 1. And then you solved for the values of y.
Mhm.
And then you just subbed in back into the equation to see what number I got. And we found out that we got 0 and 0 is not natural, which is a contradiction.
Yep, exactly.
Okay, all right, thank you.
There are many other questions like this. So I did some last year. I will do some more tonight when I cover Daria's tutorial. So if you want more practice, you can watch those as well. When I'm free, I'll finish the checklist and I'll put on my my page. But I'm teaching from 10 to 10 today, so so it's gonna take a while. Is it through Daria's link? No. Yeah, Daria's link. Yeah, it's Daria's link. I will record it as well, and we'll do different questions because it's the questions she wants to do. It's 5 to 6. I'm covering that one. And now I have a break. And I'm gonna go eat. So, guys, you need to leave now so I can go eat. Okay, 3, 2, 1. If you don't leave, I'm gonna kick you out. 3.
Lee, I had a quick question. So wait, do we join Daria's tutorial tonight?
Oh, if you wanna attend, then sure. It's 5 to 6. Daria's tutorial. I will use that link. 5 to
Okay.
6.
Thank you so much.
Where can I enter in this? Like which link?
The checklist will be posted on my Quarkus page, but it's not gonna be there soon because I need to eat and I'm teaching the whole day. Okay, bye. Everyone leave. 3, 2, 1, go.